Hey guys, it's your boy T-Dog Knights here, coming at you live with Saxon Math Lesson 73, Course 3. Alright, formulas for sequences. So, we're going to be talking about n, I assume, because that's usually what we use. When we're talking about a sequence, okay, we're talking about nth term, okay, which in this case, the first term, the second term, the third term, the fourth term, n term, which could be fifth, sixth, seventh, eighth, okay? Whatever the number of the term is, we usually use that as a lowercase n. The value of the term, okay, is going to be, we're going to call it a. So if the first term is 3, second term is 6, third term is 9, fourth term is 12, what is our equation here? Well, it seems like whatever it is n times 3, right? So first term is 1 times 3 equals 3. Second term, 6, so on and so forth. And the way we solve this is going to be pretty simple. We go ahead and we'll say second term, 2 x or 2n, or sorry, 2a. No, let's keep it at x. 2x equals 6, okay? And we'll solve. And it turns out that x equals 3. Great. But we're not done. You can't just take any one of these and do it. You have to do at least 2. And the reason for that is you need to make sure that it is consistent, okay? Because not all of these are going to be multiplication. Sometimes it's 2 plus 3 equals your term, okay? So maybe it's n plus 3 equals a, right? So we have 3, we have 6, we have 9. So it looks like it's just plus 3. However, what's the difference? If my first term is n, right, 1 plus 3 isn't 3, it's 4. So that doesn't work, okay? But you do need to figure out what the term is. 2 plus 3 wouldn't work. 3 plus 3 would be 6. So it really doesn't quite work, okay? But well, of course it shouldn't work in this one because it is multiplication. But because our thing should be n times 3 equals a. That's what we want it to look like because that's what it is. However, we need to make sure it's not something like this, okay? So we need to actually check all of our answers to make sure, or at least enough answers to be certain, okay? So the eighth terms correspond to n8 and n9, so all we're doing here is 3 times 8. It's going to give us my eighth term, 24, same. So when we're trying to find the next two terms in each sequence, okay, so here 2, 4, 8, 16, 32. Okay, fun fact, this is the Fibonacci sequence. But let's go ahead and 32, next one, you can tell that it's multiplying by 2 each time, okay? So here, our first term is 2, okay? So 2 times 2 is going to give us 4, or 2 times 1, 1 times 2 equals 2. My second term, my third term. Now, here's where it is. My third term is 6, would be 6 if I was trying this. That is not my third term here. Something else is happening, okay? I'm not just timesing the term by 2, because otherwise my fourth term would be 4 times 2, which would be 8. But that's not what's happening, okay? My equation for A is not actually n times 2 equals A. It's not what's happening. We need to figure out what is happening, okay? So we can play around with this and see. I don't know. Are they going to go ahead and tell us how to find it? When each term before it is being doubled, okay, it's a sort of a special sort of sequence. So I guess they're not asking you to find the equation for it yet. So I won't even bother with worrying about that. All you have to worry about is finding the next term. Eventually, we're going to figure out how to go ahead and write down this sort of equation as opposed to this one, okay? But I will go ahead and point out that it is different, right? In any case, so whatever you have before then multiplies here. Over here, my term is 1, 1, which is interesting, 2, 3, 5, right? So over here, it starts here and then goes to 1, and then 3, and then 5, then 8, and then 13, then 21, and then I would guess 34. Okay, so what's happening is there's a 0 here. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 13 plus 8 plus 13 is 21. 13 plus 21 is 34. Okay, so this sequence here is a whole different sort of sequence. Okay, where it actually deals with the sequence and what you have before it. Okay, this is a pattern, a very different pattern. Over here, my pattern is even going to be weirder. 1, -2, 2, -1, 3, 0, 4, 1, and 5. Okay, so what's the pattern? Well, here it's an alternating pattern. I'm subtracting 3, I'm adding 4. I'm subtracting 3, I'm adding 4. I'm subtracting 3, I'm adding 4. Okay, and so on and so forth. This is a pattern that is very difficult to try and show as an equation, but very easy to show, in a number line like this. Okay. So the rule in 2a is 2 to the power of n. Okay. So what I guess that's what they are giving in the equation. All right. So the rule here, a n, whatever that is, when it's at the bottom here, it just tells you the answer to for nth term is going to be 2 times n. So if we're talking about my third term is going to be 2 to the power of 3, okay, which is essentially 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8, okay. My next one for 2 to the power 4 is 2 times 2 times 2 times 2, which is 16, okay. So that first one, they are going to go ahead and give you the answer, or they're going to show you how to write that down, okay. And that's 2 to the nth power. So the power is what's getting bigger and bigger, okay. Over here, first 3 terms, okay, so they're not going to have you, I was going to say these two are very hard to talk about, B and C. So they're not going to have you do that yet. Find the first 3 terms, replace n with 1, 2, and 3, and simplify, okay? Yeah, so we have, in this case, we have the equation, a of n, that's how you say that, a of n, okay, equals 1 plus 2n, okay? So in this case, we have, if I'm looking for my, well, first, if we want to find the number, we'll start with 1, okay? So 1 plus 2 times 1 is going to be 3, so a equals 3, okay? If we're doing our next one, 1 plus 2 times 2, 4 plus 1 is 5, a equals 5. If we're doing our third one, 1 plus 2 times 3, 6, 7, a equals 7. Okay, those are my first ones there. 3, 5, 7. Okay. So I think you guys can do just fine with that part. If you get confused on some of this, absolutely send me an email. This can be a little weird. Figuring out sequences is actually a pretty real world aspect. We do have sequences and we try and write them down so that we can have the umpteenth number. This is used in Excel sheets. This is used in business. This is used in video games. Okay. Okay, I like 12 and 13. Let's go ahead and do let's do 11 through 25 all. Okay, and that'll be your work for today. All right, guys, have a good one.